In particle physics, the Peccei-Quinn theory is a well-known proposal for the resolution of the strong CP problem. It was formulated by Roberto Peccei and Helen Quinn. The theory proposes that the QCD Lagrangian be extended with a CP-violating term known as the theta term. Because experiments have never measured a value for theta, its value must be small. Peccei-Quinn theory predicts that the small theta parameter is explained by a dynamic field, rather than a constant value. Because particles arise within quantum fields, Peccei-Quinn theory predicts the existence of a new particle, the axion. The potential which this field carries causes it to have a value which naturally cancels, making the theta parameter uneventfully zero. Peccei-Quinn symmetry presents theta as a functional component, a global U-symmetry under which a complex scalar field is charged. This symmetry is spontaneously broken by the vacuum expectation value obtained by this scalar field, and the axion is the massless Goldstone boson of this broken symmetry. If it is a gauge symmetry, then the axion is superseded by the gauge boson, meaning that the gauge boson becomes massive and the axion is no longer observable. This is phenomenologically desirable because it leaves no massless particles, which are indeed not seen experimentally. This Peccei-Quinn symmetry is inexact because it is anomalously broken by QCD instantons. If there is a compensatory term cancelling the QCD anomaly-breaking term, the axion becomes an exactly massless Goldstone boson and theta is no longer fixed. The effective potential of the axion is the summed potential above the QCD scale, with the potential term induced by non-perturbative QCD effects. If the axion is fundamental, or emerges at a scale far higher than the QCD scale, then the dimension 5 axion coupling term is suppressed by where is the scale of the axion. Because of this, in order for theta to be so small at the minimum of the effective potential, the bare potential has to be many orders of magnitude smaller than the instanton-induced potential, compounded by the factor. This requires quite a bit of reconciliation with an approximate global symmetry, for which there is no current explanation.